Hi, I'm Jessica Oliver, here to talk to you today about the effects of training at high altitudes. While it can be beneficial to athletes, it does not come without its harms to the body. So why do athletes train at such high altitudes? According to Peterson from Live Science, the main objective is to produce extra blood cells. At higher altitudes, the air is thinner, meaning there are fewer oxygen molecules per volume of air, and therefore less oxygen is delivered to your muscles. The body compensates by producing more red blood cells to help deliver oxygen, and this lasts about 10 to 20 days after retreating to lower altitudes. This increased production is initiated by the hormone erythropoietin, or EPO. While training at higher altitude is considered legal and naturally by the anti-doping agency, the use of synthetic EPOs is not. The synthetic EPO was created as a performance-enhancing drug to imitate the effect of natural red blood cell creation. According to Higher Peak, simulated high-altitude training is also legal because it levels the playing field for athletes who are unable to live and train in elevated areas. According to Connect Us, the benefits of high-altitude training is a higher red blood cell concentration, which lasts after retreating to lower altitudes. Additionally, this training aids in endurance and performance and creates a healthier respiratory system due to the strengthening of muscle tissue in the lungs. The disadvantages to this training, however, are a weakened immune system, increased cortisol level due to the increased amount of stress, and potential increase in blood flow and possible dehydration. According to Ewan from CBC, there are some Canadian runners who use this method of training. 6 distant runners ran the qualifying standard, for example, in 2016 Rio Olympics, 2 days after returning from 3-week training camp in Flagstaff, Arizona, which was 7,000 feet above sea level. Alex Genest, one of the runners, said, "The altitude does hurt. The air is really dry, and then breathing is harder. You don't get as much oxygen. Even by the 3rd week, I still felt so tired." As seen in this picture below from Turkish Aerospace Medical Association, a high altitude is considered 5,000 feet above sea level. So now we know the pros and cons of high altitude training, but what is actually going on in the body? To answer this question, we must first discuss hemoglobin. According to McDowell, hemoglobin is a special protein that carries oxygen and carbon dioxide in red blood cells. It contains heme prosthetic groups with a central iron atom that creates a red color when bound to oxygen and a blue-red color when it lacks oxygen. Hemoglobin picks up oxygen as blood passes through the lungs due to an increase of pressure in the capillaries. It then releases oxygen to cells throughout the body where oxygen pressure is lower in tissues. The release of oxygen is facilitated when hemoglobin binds to carbon dioxide, which is later released when red blood cells reach the lungs once again. As seen in the picture from Biswas, hemoglobin is composed of 2 alpha-globin chains and 2 beta-globin chains to make 4 polypeptide chains. Each polypeptide has a heme prosthetic group attached where it can bind 1 oxygen molecule. The chemical equation for hemoglobin can be seen below, where Hb stands for hemoglobin, and the product formed is oxyhemoglobin. It is affected by changes in pressure, concentration, and temperature in the body, which relates to Le Chatelier's principle. In terms of pressure, the decrease in gas pressure at high altitudes will result in the reaction shifting to the side where there are more gas molecules. In this case, there are more gas molecules on the left, and this reaction will therefore shift left. As pressure decreases, volume increases, and more gas and oxygen molecules need to be present to reestablish equilibrium. Regarding concentration, when individuals are at high altitudes, less oxygen is available and less hemoglobin is produced, which decreases the concentration in the blood. To compensate, the reaction should shift to the left and form less products, that being oxyhemoglobin. According to Abathira, in terms of temperature, a high increase or decrease in temperature causes a denaturation of oxyhemoglobin, which results in an increase in concentration of hemoglobin and oxygen. Therefore, to reestablish equilibrium, a shift to the right occurs to increase production of oxyhemoglobin. Overall, high-altitude training is used widely, and it is legal. It does enhance performance due to the increase in production of red blood cells. However, there are harms that are important to be aware of. Thank you for listening.